Hello and welcome to the Innovate-A-Thon Discussion,
where we cover everything going on in the world of innovation, creativity, workforce advancement, entrepreneurial thinking, and enabling the next generation to do good in the world. We explore interesting topics with mentors, students, and innovators who are shaping the future. So today we have a special guest here, Richard Miltenberger, on the discussion today. So really excited to kind of dive into innovation around orthotics and prosthetics, and really talking a little bit more about breaking through a traditional mindset and really talking about some of the cool things involved in the orthotics and prosthetic space. So before we get into it, we'll give a little bit of introduction. Natalie, do you want to go first?
Yeah, for sure. So I've been with Innovate-A-Thon for about 3 years now. I started as an intern and my role has just grown from there. Now I focus on PR and outreach and our discussions now. So yeah, nice to meet everyone.
Thanks, Natalie. I'm Steven Smetsik, so I'm the director for the Innovate-A-Thon program. So the Innovate-A-Thon is a great way to bring in students from all backgrounds. We've had students in the biomedical interest in orthotics and prosthetics. So kind of through that journey, hosting our program, I've interacted with Richard and known Richard for a while now too. And Richard's been an excellent subject matter expert mentor to kind of come in alongside our mentorship in the program and really make it a great experience for the students. So thanks so much, Richard. Happy to have you here today. If you just want to go a little bit, into who you are, your background, and then we'll get into it more.
Let's see. I think I met you 2 years ago. You reached out to me on LinkedIn.
Yeah.
And we had coffee and realized, oh yeah, we have a lot of similar interests. And I got pulled into all of your projects, which has been fun. So yeah, I'm Richard. I'm a certified prosthetist, orthotist, so artificial limbs and bracing, and I've been doing that about 15 years. And yeah, probably worked in about every sector, private, government, military. Spent a good amount of time working for the Navy, and then doing some product development and product testing, and also a little bit on the software side for a couple of years, doing CAD design software. And now I have my own small practice here in the Boise region, and we see a lot of pediatrics. And so we're trying to incorporate more and more 3D printing and digital design methods into our practice. And so, yeah, it was really fun to be part of your projects over the last year and a half and get to know you guys.
Yeah, definitely. And I think, it's been really great too. And the experience kind of with the students and even students that don't necessarily have like an O&P background and getting exposed to orthotics and prosthetics and just watching you, present to students and give your background and all the insight that comes with being, a clinician and being able to understand that user experience and all that and drive that into innovative designs is just been a great experience from my perspective.
Yeah, it's always enjoyable to teach the students and see kind of the new excitement they have for a changing industry and how fast they come up with ideas that kind of mind-blowing. So
yeah, definitely. I do want to go back a little bit too. So you're a CPO, and basically for nowadays for CPO you have to go for a master's degree, and before it was this is kind of transitioning into kind of the new age, but in the old age of focusing in orthotics or focusing in prosthetics, and then having to go to school for 6 years versus like less. Could you just talk about that a little bit as kind of that start of where that traditional CPO kind of comes from, and then we'll kind of talk through like the innovative new and how they've changed all that too, just for the education part of it.
Yeah. Well, I think if you look back at old photographs and some history of prosthetics and orthotics, like you always see that there's like an innovation factor there. It's always been, it goes back to the ancient armorers who would have to fit you with armor, and then if you lost a hand, they'd probably be the guys who would be doing the smith work to make you a replacement hand. So A lot of ingenuity required there, and it's just been an artisan craftsman type position for hundreds of years, right? And before my time, it was more of a heavily technical job, and then when I joined in to the profession, it was more and more becoming kind of a recognized medical profession, and it was something that attracted me to it because having a background in construction, I could do a medical job, but also incorporate hand skills, making things and helping people. Also, it's really just taken off, with the advancement of materials technology, and now 3D printing. When I was coming into the field, it was all about the microprocessors. Those were new, and insurance wasn't paying for them really yet, and so just to see those become kind of commonplace. And of course, I get a lot of questions about upper extremity, the new hands that are coming out. There's been huge advancements with computer chip technology to be able to read the signals from the muscles, all of that. I think that kind of milieu is what draws people to the profession and what keeps it interesting. But then, at the end of the day, it's something that you're there trying to solve a problem for a patient, and using all the tools at your disposal to do that. And those tools change throughout the decades. So, before we had plastic, we had metal and leather and wood, and then laminates and plastic came into being, and that shook it up. Now we have kind of a new shakeup, which is 3D printing. And kind of like the old shakeup, it doesn't cover everything. It doesn't cover all the bases. So we have to mold and fit the two together into how do we incorporate a new technology that doesn't do everything for us. So it's always been, a profession that stays interesting. And I liked that it was kind of always emerging and changing and had a big future, I thought. So that's proven to be true.
Yep. Yeah, and I think too, admittedly, my kind of same attraction to it was that, it seems like an industry where innovation's kind of allowed in kind of the up and coming, and it can be a slow process. Like there's still, reasons to use traditional processes and things like that, still more heavily, and you still have to make a justification to use, a newer type of technology like 3D printing. But it's almost like this active innovation process of, like you said, it's like more hands-on. You get to almost, I don't want to say this too much, but experiment enough in the process of trying out, different devices and strategies around, making a patient more comfortable, making better outcomes for patients. And like the innovation process is almost like baked into the actual ongoing process with patients, which is kind of unique. So yeah,
that's a great point. You kind of have macro innovation and micro innovation. So, you'll have these macro innovations like urethane gel liners, that they didn't used to have that material that they could use. But then on the patient-focused side of it, we have to just use whatever's at our disposal to make that patient comfortable and functional and have the best life. And so we're always changing things up. You go in with a plan, and then you realize that we've got to take a turn here. Maybe they can't use the strap the way that you want it, so you've got to invent a new kind of strap, move it to a different place on the device. You've got to, invent a new suspension system for this patient, or maybe even just a padding system that makes them comfortable. Everyone is different, so it's never a one size fits all. It's like literally not. It's like one size fits no one. So everyone's shape is different, and everyone's expectations and goals are going to be different. So yeah, there's a lot of micro innovation. I end up trying to plan for a patient and then always go into the back and troubleshooting, problem solving something. So that definitely keeps it interesting.
One thing that I was researching just this morning that I was like, whoa, this is crazy. You'd probably define it as like a macro invention, was a prosthesis driven by the nervous system to help people walk like more naturally, like their gait is more natural. So basically, like the procedure gives people like neurofeedback to the prosthesis device that they're using, so they can walk more naturally, like navigate things differently, like walk up the stairs with a more natural gait. And that was kind of crazy to me, because I was like, how do they like connect it to the nervous system? But somehow way out of my wheelhouse, they do some science thing that I'm like, whoa, how do you guys do this? But even the way, like there was a video and the people are like walking up the stairs, and it looks so much more natural compared to like how just like normal prosthetic devices are. And it's just like they connected it somehow to the muscles and everything that's like all connected through this device. So that was super interesting and crazy to me.
Yeah, that's a really cool innovation, and a lot of those technologies are coming out of the universities, and that I saw a talk years ago, and that's one reason I went into prosthetics, is because they were starting this nervous connection pattern recognition of the nerve signals. It was just fascinating to me, and it still continues to get better and better. So it's very exciting to see technologies like that, which are not industry standard yet, but the ones that were coming out a few years ago are now industry standard. So there's always change coming down, and we have to adapt. It's really cool for patients.
It might not be industry standard now, but who knows, like 10 years from now, we could be able to like just snap it out real quick and be like, oh, here's your new device connected to your neurons, or whatever little thing that they do. Like,
yeah. I think too, that the kind of the process of, and we went through the Innovate-A-Thon program too. There's really expensive devices that, as more insurance reimbursement and all that kind of follows basically the technology, right? It becomes more and more adoptable, more people have them. And so, and I think we had Kevin Falk, on the podcast too. And
good, yeah.
During the episode. And different types of legs and different devices. It's always funny to talk with him too about all the different types that he's had, and then eventually you're able to get enough insurance coverage to be able to get like a better device, and just incorporating all those technologies over the year. And it's great when it's able to evolve to a spot where you can see all the actual outcomes, and then it affects a wider population of people too. So
the more it's used, the more the price will drop. And
yep, exactly. Yeah. And I think
going with AI.
The 3D printing space too is kind of interesting. I am interested in all the, electrical, myoelectric and all those too. They're super fascinating, but 3D printing too. And the reason for bringing it into kind of, it can actually be like a medium cost, not a full, electric, myoelectric type setup, but kind of incorporating some innovation around just better geometries that mimic like the body, being able to use 3D printing for what it's good for, to make complex geometries work better for devices. So, and being able to do it easier. And then the price drop of materials and things start going down. You've seen like the adoption of it happen, faster over the last several years, right? Of having like every O&P practice is at least having a printer and doing at least, test devices and some aspects of it now to be able to prove out things. And then they might still use traditional, but they mixed it in now to, the innovation that happens even at small clinics. So, yeah,
that's been a big change.
I think one thing too, because you mentioned AI, like I wonder how AI is gonna like play into the O&P design in the future. Like, is it gonna be something like, Alexa, scan my leg and order me a new prosthesis, and then it shows up in like 2 days or something through Amazon? Like, it's gonna be interesting to see how that all plays out and how it factors into it.
Yeah, and I think
I think you can never separate the personal care aspect. Until we have a robot that replaces me, which is entirely possible. I'm not that smart, so But yeah, the kind of a lot of people have envisioned that idea where it's like scan your own leg and then you get a leg in the mail, and I could see that potentially that could happen many years in the future, but it's going to take a lot of know-how. And there's a lot of on the ground alignment that needs to happen too. So it's not just about having a straight pole under your leg. It's about
making sure it's comfortable and like the straps aren't too tight and that there's enough padding, and when you walk it's even and it's not uncomfortable.
Yeah, exactly. Uneven gait and whether it's comfortable or not. And these are things that you can't really know until you put it on and have someone who knows how to walk back the complaint to figure out what the problem is.
Yeah.
And I think too, Richard, we won't go into too in depth, but if you could give just a real brief overview, because you use kind of a hybrid method, for what you do, and you use scanning and you work in 3D printing in different ways, and it's really interesting because I know just enough now to know how complicated it can get in the process of getting all of the patient information and the data from their body basically, and then driving it into a good design, but still having all of your influence, and your background as a CPO in the process.
It's been an interesting transition, and we're not fully there yet. So kind of my plan is to really get as good at scanning and comparing the scan to the cast, and teasing out the differences, and figuring out where can we go with the new technology. A lot of people are on board with it already, scanning in particular, but there's so much that you learn just by using your hands on a patient, because you can feel your own leg. Like you can touch the outside of your leg, but you could also push it in about that much, right? So where's the happy medium that will feel good to the patient, right? You also can move a foot and ankle back and forth and side to side. It moves in a lot of different directions. So it's not just about taking a picture, it's about taking the picture in the right position.
And like seeing maybe like they have a limited range of motion here, which like the picture or the scan can't see, like, oh, they have a range of motion when they move their foot up, or they have like a limited range of motion when they move it down. So that's kind of important to consider too, that I didn't think about.
So your assessment, exactly, very good point. I mean, your assessment is key, and if you miss something there and you scan the patient and it doesn't match the assessment, then the cool part is the software can fix a lot of things. So you can go in there and move things.
So you don't have to go completely back to step one.
Yeah. I have some printed molds here I could show you in a minute that kind of show my point there. But yeah, we're working on incorporating scanning and 3D printing into the practice. We're using various print bureaus to try new devices and see what different materials do. Where do they stand up? Do they hold up? Do they have the same properties? And it's all kind of subjective, right? Subjective for the patient, subjective for me. So it's been a process.
Yeah, and I think that it's super cool to see, and there's been a lot too, right, of companies coming out with like new automation software around O&P, different softwares that complement O&P in different parts of the process, different scanners that are more attuned for O&P, and then even all the way down through you can have a whole like digital ecosystem now around doing things more digitally, and it's just been crazy to see the amount of like companies trying to come out with these new innovative either softwares or platforms or things around kind of the ecosystem. And that's why too,
I was a part of one.
Yeah, exactly. So and so you work for Mercurus for an amount of time, and I think that attraction, and I kind of knew what they were, I think, before. I didn't have a good idea, but how much like that digital manipulation of like body anatomy and all that can happen inside of software now, it's just is kind of fascinating.
Yeah, it's
and
come a long way. It's really amazing.
Yep.
There's people, who've been doing it a long time, Brent Wright and others, who are really good at it. I think a lot of the softwares now are trying to aim at people who are busy, who don't haven't learned standard CAD software, and that's most of us. And kind of you can bring in your scanned mold that you've modified, and then something snaps onto it. That's kind of the goal. And that, yeah, it's come super far. It's really neat to see.
Yeah, and just the exposing students to this, because a lot of students don't even know that there's like this whole ecosystem around ONP. And when if they have at least some biomedical interests, and a lot of the students that have come through the program do, you start explaining to them like, oh wow, yeah, there's this whole entire like digital traditional hybrid process that like happens. And then there's a lot of people trying to innovate in this space too. Like they're trying to take advantage of all of these things that are coming out now, with 3D printing, with software. And it's just a great space to work in. And then throw on top like that artisan type, like it's almost encouraged in this space to innovate, at least to a certain point. And it's just so cool to be in that, and then expose, younger people to the biomedical, that might have a biomedical, or they might want to become a CPO, interested in this same space. And once they see all these, and as an engineer too, like with very visual, like shiny object syndrome, it is a very cool space to be able to go in, and it's very hands-on. You can make something digitally, or be a part of the first part of the process and see it come and become and worn on a person in a very short amount of time. And like it's just it's so cool to be in that kind of process. And then, like I said, have more and more students involved in that, because it's eye-opening when you're involved with it. So
it's really, if any students that know you or watching this want to reach out, I'm happy to chat about any of this stuff. Do you want me to show some of the shiny objects yet? Or are we ready?
Yeah, no, I think that's a good, I wanted to kind of segue, like, speaking of shiny objects, so we're going to go into kind of, show and tell segment. We'll bring on, different things here. It looks like Richard brought a lot today too. I'll let you start.
Some of my best projects are out on patients. So, but I'll mention a few things that I really like about the new materials, right? For prosthetics in particular, how lightweight the materials are. There's also the fact that it doesn't change from one mold to the next. So something we kind of discount in our standard plaster workflow is how you can make minor changes over time, and that, with the digital file, doesn't change at all. So I have a less shiny object here that is a standard plaster mold. If you can see that, you can see the little scrap of plastic. We vacuum form over this mold, right? And you can see the cut marks maybe along the front. There's the
like the arch.
The arch. The interesting thing about this model is I actually scanned the kid. So I scanned his foot. He was a squirmy kid, and so I only scanned one foot, and then I made it to my specifications and then reversed it to the other side too. We printed the mold, which didn't take very long, for a mold like this size. It was like less than an hour. And then I fabricated it traditionally. So that was it was very easy for the patient, easy for mom to sit there for 30 seconds while I took a scan. And then we were able to make a nice product. So that's kind of one hybrid way. So just to show you, let's see, I've got a few molds. Like this is a kid that's, you can see, like you're talking about the ankle range of motion.
Yeah.
You see that he cannot reach to 90 degrees. Like the floor is down here.
Yeah.
That is his problem. So you need to get their heel straight up and down. And so we were able to manipulate this in the software and then print this tooling model. And we're going to use that in the fabrication. Usually the ultimate goal with the digital workflow is that we would skip the tooling and we would go straight to the final device. So for that, we can do, this is a very basic one, kind of an old sample. Like I said, a lot of my samples are kind of out on people, but this is the MJF nylon that we all know about. It's very stiff.
Okay.
Very, very lightweight. You can do cool stuff like holes in the back and all that. So, it's a nice material and kind of something that a lot of people in O&P have landed on is working well because it's nice surface finish and all that. Works great for prosthetics. So I don't have any full prosthetic sockets, which is like the interface, right? Because patients are out walking on them. But I will say that each fitting we've had has been incredibly successful with 3D printing for prosthetics, and the patients have loved the materials. And so it's really, really promising. Yeah, I got a little insole here. This is printed with a flexible, soft material, that VarioSure. And then to your point earlier, Stephen, with the geometry, I have this nice sample where the padding's kind of incorporated into the device. This is from Brent. So he's got like a bulbous area here.
What is that for?
So this is the leg below the knee, so the knee will sit here.
Mm-hmm.
So this would be kind of the outside of your leg, and that's a typical pressure point. So you can build up air pockets and patterns here to not only make the device lightweight and
but more comfortable for them to wear.
Improve the geometry. I mean, this is really light compared to our standard materials we use. So, and you can incorporate padding and distal end padding. It's really nice.
That's nice.
Also, this is a flexible one. That's key for a lot of our stuff.
Yeah, and I think just showing that, and as soon as you start showing that to the next generation of people that are going to come into, I can only imagine, right? 10 to 20 years from now, and where will O&P be? And it's just being able to see, what you're working on, and all of the innovations that have happened just in the last few years that I've known you too, and people trying things out. It's just been great to see. And I think, the one thing I'll show too, because we're doing show and tell, and so I met Richard. I actually asked him to come work on a student project, was kind of one of the first interactions. And then this is a heel orthotic, and then again it has kind of a complex lattice structure built into the bottom. So it kind of acts like a heel lift, and the goal of the product for that team was to kind of mitigate heel pain, try to mimic at least a little bit of traditional methods that are used. And I brought this one too because I was trying to find it. You can buy these kind of traditional off the shelf, and they might even have kind of complex, shapes on them to mitigate like heel spurs and other things like that. But with 3D printing, this has depth to it. So it's basically got, layers of lattice structure that can do different things that you just can't do with traditional methods. And you can start taking in anatomy data and all of these points around like a particular person or a patient and drive that into their device to make it more comfortable, could ease their pain more. It could, do a lot of things for them. And so, just being a part of that, the innovation process around 3D printing, that's a lot of my background too. It's just general 3D printing in different industries. But getting to work with you, getting to work with students in the Innovate-A-Thon program now too, and bringing in all of these elements, showing what they can do in something like an O&P space, and being able to innovate. Like you said, it's kind of baked into the O&P industry of progressing forward. It's just been a great opportunity for our program. And I always like to say thank you too for the things you've done through the Innovate-A-Thon program this last year too, and bringing in all of your great background and just contributing and helping push innovation forward. So
it was my pleasure. It's been super fun.
Cool. Well, I think I'm going to go ahead and I'm going to give us a little sign off here. Yeah, thank you so much, everybody, for joining us today on the Innovate-A-Thon discussions. Thank you so much, Richard, for coming on today, discussing all the great things going on in innovation in O&P. We hope to see you again next time on Innovate-A-Thon discussions. Thank you so much.
Bye, guys.
Bye, everybody.
Thanks.